Special A9 TV interview with Professor Michio Kaku, co-founder of string field theory. Part 1. Michio Kaku, the famous scientist of Japanese ancestry, is a theoretical physicist born in the United States of America. One of the most prominent physicists of recent times, Professor Kaku has written many books and has appeared in countless radio and television programs. Michio Kaku is known for his contribution to the popularization of science and has researched such subjects as black holes and the expansion of the universe. He is also one of the founders of string field theory, one of the basic models of physics.
We have the illusion that things are solid when actually things are empty. So why is it that we don't fall to the floor? Why is it that things look solid? Because electrons repel each other. So I'm not really standing on this floor because electrons don't like each other. They repel each other, and that's why we have the illusion that things are solid when actually there's nothing here. Things that are solid are not really solid at all. We have the illusion that they're solid. But we think of reality as being solid, but it's really not that way at all.
So we're living in our brains.
In some sense, when you look at the mirror, you're not really looking at yourself. In a mirror, you're looking at yourself as you were 2 billionths of a second ago, because that's the time it takes for light to go from your face to the mirror and back again. And then according to quantum mechanics, your face is actually a wave. You're actually vibrating. That sounds incredible. But we measure this with our instruments in the laboratory. And so when you look at a mirror, you're not really looking at you. You're looking at an average of what you look like.
If we see, touch, hear everything in our brain as electric signals, how can we know that matter exists outside?
Our brain averages what we see. So you're asking the question, is it possible to fool the brain? And the answer is yes. But the question is reality fake? I mean, is everything we see around us fake? You think this is reality, but it's really not.
It can be an holographic universe.
And perhaps be unaware of the difference between reality and unreality. Now we're beginning to create artificial touch. This is called haptic technology. We're able to create the artificial sensation of touch when there's nothing there.
But let's talk about the real world. Or at this moment, can we understand that are we living in a dream world or a real world?
Well, in principle, the world that we see around us may be a dream world. You cannot disprove that theory.
The matter, atoms are completely dark with 99% nothingness. So how we do see a colorful three-dimensional world?
We see a world that is an illusion. So it has the illusion that we are solid, the illusion that we can touch things. For example, I'm not really sitting in this chair.
How is it possible?
I'm not really sitting in this chair. I'm hovering, floating 1 angstrom above the chair, because electrons do not like to be in the same quantum state. They repel each other. Now, why is it that my hands don't go through each other? Why do we have this illusion that I'm solid, right? And the reason is when I slap my hand does not really touch my head at all. It bounces off my head 1 angstrom away. So we have the illusion that things are solid when actually things are not.
Okay, we said that we interpret electric signals coming from the outside world. Okay, what is the being which interprets electric signals as light, color, sound, smell and taste?
Well, we don't really know, and it's specialized, so certain parts of the brain create an image of you in terms of sound, in terms of smell, in terms of sight, but it's not really you.
Yes, it consists of electric signals.
That's right.
Special A9 TV interview with Professor Michio Kaku, co-founder of string field theory. Michio Kaku, the famous scientist of Japanese ancestry, is a theoretical physicist born in the United States of America. One of the most prominent physicists of recent times, Professor Kaku has written many books and has appeared in countless radio and television programs. Michio Kaku is known for his contribution to the popularization of science and has researched such subjects as black holes and the expansion of the universe. He is also one of the founders of string field theory, one of the basic models of physics.
Let's ask a question about the dreams. So the dream world and the real world.
Right.
How do we feel the hardness, see the colors, feel the temperature of matter in our dreams although they don't exist? And what is the difference with this so-called real life?
Using brain scans, we see what the person is doing when they dream. When you are awake, your occipital lobe back here responds to visual stimuli from the eyeball. When you dream, that same area of the brain lights up. So the brain is creating fictional images in the occipital lobe back here.
Okay. Can you be sure that there is matter outside of our brain? For example, I touch this microphone. Okay, how can I be sure that there is a microphone outside of my brain? Because I touch it, I see it, I hear it, everything in my brain with signals,
Right.
electric signals.
There is a philosophy called solipsism. And the question is, if a tree falls in a forest, did the tree really fall at all if no one's there? So the solipsist would say that the world is a dream, that we exist in a dream, and that we don't know whether things really fall or not. Now we have the quantum theory, which is even more bizarre than solipsism. The quantum theory says that before you look at a tree, the tree can be upright, fallen, toothpicks, burnt, a house, or anything you want. When you look at it, it turns into a tree. In quantum theory, the Bohr interpretation says that the process of observing something determines its existence, which is worse than solipsism. So then the question is, Schrodinger's cat. Schrodinger's cat is one of the deepest of all paradoxes in all of science. If I put a cat in a box, is the cat dead or alive? In quantum mechanics, we take the wave function of a dead cat and then we add it to the wave function of a live cat. So the cat is neither dead nor alive. It's in between. So how do you know if a cat's dead or alive? You open up the box. But that requires an observation. Observation requires consciousness. So consciousness, in some sense, determined existence.
Did you watch the movie Matrix?
Yes.
And what are you thinking about its philosophy?
I think that as a philosophy and as a science, we will be able to create a world almost like the Matrix. So we can use the brain directly to control objects around us. That's today. What we cannot do is input memories into the brain. We cannot do that yet.
There was a question in that movie. He was asking, if you are dreaming and you cannot wake up, how can you be sure that you are dreaming or you are not?
Well, you can't.
You are saying that the brain is like a computer. It's a supercomputer, but it consists of meat.
It's wetware rather than hardware.
Yes. How is it possible that it became flesh?
Well, if we were to take transistors and model the brain, neuron for neuron, we can calculate how big that computer would be. That computer would be the size of a small city. It would consume about 1,000 megawatts of electrical energy. That's the output of a nuclear power plant. It's very hot, too, because it generates electricity. You would take a river to cool it down. So if I have a small city, a computer the size of a small city, water coming in from a river, and a power plant, a nuclear power plant energizing this gigantic computer, that's the brain. But our brain does not generate 1,000 megawatts, it generates 20 watts. 20 watts. It's not the size of a city, it's this big. How's that possible? Because first of all, the brain is not a computer. We used to think the brain was a computer, but now we know that it's not. There's no Windows, there's no Pentium chip, there's no programming, there's no Windows, there's no subroutines, nothing. So how does the brain work? The brain is a learning machine. It rewires itself after learning every task. So that's how the brain does things that even a digital computer cannot do. Digital computers cannot learn. Your laptop today is just as stupid as it was yesterday, just as stupid as it was the day before yesterday. Your laptop never gets smarter. But your brain, that's all it does. All it does is it learns new tasks. That's why the brain is really not a computer. The wiring is different. And that's why it takes a city, a computer the size of a city, to act like a brain.
Okay, thank you for your time.
Okay?
Thank you very much.
Great.
Is there any
Michio Kaku, The famous scientist of Japanese ancestry is a theoretical physicist born in the United States of America. One of the most prominent physicists of recent times, Professor Kaku has written many books and has appeared in countless radio and television programs. Michio Kaku is known for his contribution to the popularization of science and has researched such subjects as black holes and the expansion of the universe. He is also one of the founders of string field theory, one of the basic models of physics.